Welcome back to Hardware Unboxed. Today we are breaking out the 32-core Threadripper 2990WX for some VRM torture testing. If you recall, late last year I took 4 flagship X399 motherboards and put them to the test, and of course the focus was on VRM thermal performance. So we compared a number of configurations to see which board kept its cool the best. The most extreme board of the bunch was MSI's X399 creation, a 16-phase monster that handled the 2990WX with ease. It was the only board to do so without active cooling, an impressive feat indeed. With the 32-core processor running at its stock clock speeds, all tested boards passed without an issue, even in our no airflow test. But then, as we overclocked the 2990WX to 4 GHz using just 1.25 volts, we had our first victim. The ASRock Fatality X399 Pro Gaming failed. Then for our extreme unrealistic stress test, the Gigabyte X399 Aorus Extreme failed, leaving just the MSI X399 Creation and Asus ROG Zenith Extreme standing. The Asus board provided the best thermals, but it was also quite loud with that 40mm fan screaming to keep the temperatures under control. In a somewhat makeshift effort, Asus did develop an upgrade kit for the Zenith Extreme that added a 40mm fan directly to the V-Core VRM heatsink. We never tested this, but with more loud 40mm fans, this isn't exactly an ideal solution. So, Asus has recreated the Zenith Extreme as the Zenith Extreme Alpha. Yeah, they really need to work their naming out. So, basically what this means is we now have the Asus ROG Zenith Extreme Alpha. And boy oh boy does that abuse the hell out of my 2 words per product name rule. Anyway, the Zenith Extreme is a completely new beast. Actually, it's a really heavy beast. I'll sit this down here as I talk about it. So Asus has been forced to push the 8 DIMM slots down to make way for 16 power stages. And this is the same thing MSI had to do with their creation. However, whereas the creation has a 16-phase VRM, this board has 16 power stages, but despite that, it doesn't have a 16-phase VRM. Asus maintains that opting to neglect phase doublers is the way to go. They say doublers introduce a processing delay of 20 nanoseconds and increase operating temperatures. They did provide us with some information, as well as some thermal imaging for the Zenith Extreme Alpha, apparently with and without phase doublers, and the images they showed us with phase doublers, the board was running about 4 degrees hotter. Of course, without the 2 different versions to test for ourselves, we'll just have to take them at their word. None of this really matters. What matters is how well the Zenith Extreme Alpha stacks up to MSI's X399 creation, and we'll get to that in a moment. The Alpha still isn't a completely passive board, though it is much closer than the original. There's still 2 tiny VRM fans integrated into the main heatsink, but by default these little guys only spin up when the VRM temperature exceeds 60 degrees Celsius. That said, you can completely customize how they work in the BIOS by using the manual fan profile setting. Now, this isn't a motherboard review per se, rather it's just a look at how the board's VRM performs thermally under heavy load. Since I did do that X399 VRM thermal testing roundup late last year, I felt it made sense to update that content with the new Zenith Extreme Alpha. That said, before we get into the thermal results, I would like to just quickly touch on a few features of the board and highlight what's new. For starters, Asus has integrated the 10 gigabit networking into the board. The original version included a PCIe expansion card to support this feature. The 8+4 pin CPU power input has been upgraded to an 8+8 pin configuration, and while we've already gone over the V-Core portion of the VRM, the VDD SoC has also been upgraded from 2 power stages without cooling to 3 power stages with a heatsink. The Wi-Fi has also been upgraded, whereas the original version supported transfer speeds of up to 866 megabits per second. The Alpha's good for 1.73 gigabits per second. Bluetooth support has also been upgraded from version 4.1 to 5.0. The U.2 port's been dropped in favour of 2 SATA ports, which I'm happy to see. This takes the SATA port count from 6 to 8. There's also 2 extra USB 3.1 Gen 2 ports. There's also a few other Asus features that have either been added or upgraded, such as ROG RAM Cache 3, ROG Node, the Fan Connect 2 module, and BIOS Flashback, for example. But I think that's enough about the board. Let's get into the VRM testing. To apply load to the system, I'm not using a PowerBug type program like Prime 95. Nothing against using that kind of software, certainly has its place, but for this kind of test I really want to use a real world application, so therefore I went with a Blender workload, and the workload that we use takes the 2990WX a little over 20 minutes to complete. So for the hour-long stress test, we are running 3 back-to-back runs. The load results are reported after the hour-long stress test, and we're reporting the peak temperature, and then the idle is taken after a 10-minute cooldown period. There's 3 main tests in total. First, we're looking at the stock results. So that is the stock out-of-the-box 2990WX performance. Then we have a 4 GHz overclock using just 1.25 volts. So somewhat of a realistic overclock there. But then we have a unrealistic, ridiculous stress test at 4 GHz using 1.4 volts, just to see what these boards are made of. All 3 tests are conducted twice, once on an open air test bed with no direct airflow over the VRM. Though, take note that the Asus and Gigabyte boards do have small fans, so they aren't truly passive, and therefore they do kind of cheat on that test. Then we have a second test configuration inside the Corsair 500D with 3 120mm intake fans in the front, 2 120mm intake fans in the top, and then a single 120mm exhaust fan in the rear. So the top mounted fans are pushing airflow directly over the board's VRM heatsinks. Then cooling the CPU was the Enermax LickTech 280, which was mounted in the front of the case. For recording temperatures, I'm using a digital thermometer with K-type thermocouples. I've placed multiple sensors on the surface of multiple power stages to measure the temperature across the VRM, and I'll be reporting the highest value. So this means I'm measuring the temperature directly on top of the component between it and the thermal pad, and not an internal temperature, which is bound to be a little bit higher. Still, with all boards tested under the exact same conditions, it will give us a clear idea of how they compare. Starting with the open testbed results, which sees no direct airflow over the VRM heatsinks, we have the stock 2990WX temperatures. Again, remember the Gigabyte board packs 2 35mm fans, and the original Asus Zenith Extreme a single 40mm fan, while the MSI and ASRock boards are completely passive. Then we have the new Zenith Extreme Alpha, which has 2 small fans, though by default they only spin when the VRM exceeds 60 degrees, which in this test it didn't. Here we see the Alpha hitting just 59 degrees, and this did cause the fans to twitch every now and then, but they never really fully fired up. This is a 2 to 3 degree improvement over the MSI X399 Creation and the original Zenith Extreme. So a solid result, but without an overclock, we're not really taking advantage of these high-end motherboards. Okay, so time to overclock, and at 4 GHz using 1.25 volts, the Alpha was a degree cooler than the original Zenith Extreme, and that would certainly be within our margin of error. The completely passive MSI X399 Creation also does very well in this test, given it's the only board not aided by an active fan. Then finally, the extreme stress test using 1.4 volts, and it's here that the Zenith Extreme Alpha really starts to shine. The small fans were spinning, but honestly they weren't very loud, certainly much quieter than the fan featured on the Gigabyte X399 Aorus Extreme and the original Zenith Extreme. The Alpha is almost 18 degrees cooler than the X399 Creation, though I feel this is a bit unfair, as a small fan would certainly help bring down the temperatures for the MSI board in this zero airflow stress test. Now, with the boards installed inside the Corsair 500D, we have direct airflow over the VRM heatsink, so this will no doubt help reduce load temperatures. In fact, we see just 5 degrees separating the MSI, Asus and Gigabyte boards. The X399 Creation does very well in the stock test, while the Alpha was a few degrees cooler than the original Zenith Extreme. Moving on to some overclocking with airflow, we see that the MSI X399 Creation does much better this time. We're basically seeing the same performance out of the Creation, Zenith Extreme and Zenith Extreme Alpha. Finally, we have the most extreme stress test, which sees the 2990WX running at 4 GHz using 1.4 volts. Here we're yet again seeing basically the same performance from the Zenith Extreme Alpha, along with the Creation. The Zenith Extreme Alpha is a quieter board under these extreme test conditions, but as you can see, the actual temperatures aren't really any different. Okay, so last time I did our VRM thermal testing, I concluded that the Asus ROG Zenith Extreme rivaled the bigger, beefier MSI board. I went on to say though that for extreme overclocking, the MSI board will ultimately win out, but for a more typical overclock, 1.25 to 1.3 volts, there appears to be little difference between the Asus and MSI boards. Both ran at just over 70 degrees when installed in our Corsair 500D test system. Now, with the Zenith Extreme Alpha added to the mix, Asus does have a high-end X399 motherboard that can rival the Creation for extreme overclocks. Having said that, I suspect that this won't mean a whole lot for most of you. Running the 2990WX at 4 GHz, maybe up to 4.2 GHz with 1.25 to 1.3 volts can easily be achieved on either of the Asus boards, whether that be the Zenith Extreme or the new Zenith Extreme Alpha. But it is nice to know that the Alpha is built to do it more comfortably. The Alpha is a more refined offering with some nice features. Having said that, I nearly spat my coffee all over my screen when I saw the price. It's $650 US. Admittedly, for an extreme high-end X399 motherboard, that's not absurd. The MSI X399 Creation, for example, that was selling for around $600 not that long ago. But the original Zenith Extreme did only sell for $520, and today MSI's Creation's also selling for just $520 US. This is a small issue because if I were buying a Threadripper 2950X or better, I'd consider my motherboard options to be the MSI X399 Creation or Asus ROG Zenith Extreme Alpha. Of the two boards, the Alpha is probably the better offering. As a workstation grade product, I certainly appreciate the inclusion of 10 gigabit networking, but I'm not convinced that the fat 8-phase VRM is any better than MSI's doubled 16-phase. But I suppose it doesn't really matter. They both handled the overclocked 32-core processor with ease. In the end, if you require 10 gigabit networking, then I think you'll agree the Zenith Extreme Alpha is the obvious choice. It also helps that the board looks great, it's loaded with tons of really good features, and it has that glorious Asus U EFI BIOS. With the exception of the price, there's really nothing negative or no drawbacks that I've come across with this board in my testing. It's a really solid product from top to bottom, and certainly one of the best, if not the best, X399 motherboard on the market. Again, this was mostly meant to just be a VRM test, but I did spend quite a few days playing around with the Zenith Extreme Alpha, and I really do like it. And that is going to do it for this one. If you did enjoy the video, be sure to hit the like button, subscribe for more content, and if you appreciate the work we do here at Hardware Unboxed, then consider supporting us on Patreon. Thank you for watching. I'm your host, Steve. See you again next time.